good morning, wherever you're joining us from. My name is Scott Davis, and this is my co-host, Brandon Byers. It's my sincere pleasure to welcome you to the 2021 North American edition of the Thoughtworks XConf Software Conference. Thoughtworks is a global consultancy of over 10,000 technologists spread across 20 different countries. But what you are about to experience today is what 20 of us right here in North America have been thinking about for the past year and what we've been working on most recently with our client partners. After today, I encourage you to go online and look around for talks from XConf Europe, XConf India, XConf Southeast Asia, and even XConf Australia. You see, Thoughtworks has been running XConf software conferences around the world for nearly a decade now. So you'll be tapping into a rich history of where we've been. But today, you'll get a chance to hear the freshest perspectives on where we think our industry is headed from the hands-on technologists who are working with tomorrow's technologies today.
Thank you, Scott. And I'm particularly excited to kick off XConf North America. It's been a little bit of a lag since our last one. It was 2018 in New York when we last ran an XConf North America. And we decided not to let the pandemic get in the way of doing one virtually. We'll begin today with Thoughtworks CTO, Dr. Rebecca Parsons. She recently co-authored a book with some of our colleagues called Building Evolutionary Architectures. She's here to talk about the past, the present, and the future of architecture. Following her, we're going to hear a range of topics today, specialists in data, artificial intelligence, machine learning, virtual and augmented reality, and more. Particularly excited about a talk later in the day around data mesh from one of the pioneer implementations of it, teeing up a book that's shortly going to come out by Zhamak Dehghani, who came up with the idea of data mesh. We're also going to hear from a range of topics about some of the fundamentals of digital transformation. We'll hear about observability, lightweight architecture governance, product innovation, optimizing the engineering value stream, metrics, developer portals, DevOps culture, information discoverability. I'm really excited about the range of topics that our speakers will present to you today.
The opening keynote this morning is the past, present, and future of architecture. Dr. Rebecca Parsons is Thoughtworks CTO. She has more years of experience than she'd like to admit in technology and large-scale software development. She recently co-authored Building Evolutionary Architectures with colleagues Neil Ford and Pat Kwa. Before Thoughtworks, she worked as an assistant professor of computer science at the University of Central Florida after completing a director's postdoctoral fellowship at the Los Alamos National Laboratory. Her interests include parallel and distributed computation, programming languages, domain-specific languages, evolutionary architecture, genetic algorithms, and computational science. Rebecca received a Bachelor of Science in Computer Science and Economics from Bradley University, and both a Master's of Science and PhD in Computer Science from Rice University. With that, I'd like to turn over the stage to Rebecca and welcome to the opening of XConf North America 2021.
Thank you, Scott. And hopefully everybody can see that. I'm really happy to be here today. I want to give you a little bit of a tour through architecture. But first, don't worry, I'm not going to try to define architecture. We all know that you can't really define architecture. I am going to argue, though, that we need to set aside the standard characterization that architecture is the stuff that's hard to change. But architecture is many things. In fact, when I started as a computer scientist, most people, when they talked about architecture, they actually thought about the specifics of the chip. You've got your buses and you have your memory, and that was what architecture was. Computer architecture was primarily about the hardware. And part of the reason for that is software architecture was not terribly interesting at that time. Most things were run on mainframes. Now, you've always had this little side thing with people doing things in programmable controllers, very, very low level. And so when I started, there was quite a split between what people considered business computing, which was all done on mainframes, and then that other stuff. But architecture has evolved from that, where we start to think not only about what is the hardware, but how does the hardware interact with each other? What is our software architecture? How are we decomposing the problem into various components that will then run somewhere on hardware? So our notions of what constitutes architecture have been evolving over time. And architecture is necessary. Many people within Thoughtworks over the years have said, why do you keep talking about architecture and architects? Because we don't need them. Well, actually, we do. Just because there are people in this world who don't necessarily do the job of architect well, doesn't mean that there isn't a job to be done. We do need to think about architecture. And the way I like to characterize this is a software delivery team, their primary focus in all of their processes are fine-tuned to deliver business value as quickly and as efficiently as possible, and to deliver high quality as quickly and efficiently as possible. So they have a short to possibly medium term time perspective. Architects need to step back from that. They need to look at the bigger picture. Architects will tend to have medium to long-term perspectives. And when we get to the level of enterprise architecture, that architect's responsibility is really the enterprise value of the entire IT estate of that enterprise. And somebody's got to worry about that. Somebody's got to worry about what do we need to do to maintain the enterprise value of our IT assets. And that's what architects care about. They care about that longer term. And so it's not surprising sometimes that there's tension between people who want to go really fast and people who are worried about the long term. But architecture is necessary to think about at all of those different levels, even if much of how architecture has been done in the past is not something that we think is still relevant. And particularly not within the context of today, when we need to start worrying about evolutionary architecture because the pace of change is simply so quick. And when I talk about evolutionary architecture, I'm talking about something that supports guided, as in we have a specific definition for what constitutes good for our systems in our organizations. Incremental change, because we're fundamentally inspired by Agile principles, Agile practices, the Agile mindset. And then across multiple dimensions, because as architects, we have to worry about scalability and reliability and security and maintainability and all of these ilities. And so when we think about architecture, we can't just focus on one module or one concern. We have to look at how all of the concerns work together. And an architect's both favorite and most hated word is the trade-off. Favorite because we say it all the time, hated because we don't like to make trade-offs, but we have to. So how did we get here? Let's take a little stroll. First, through architecture. Architecture used to be simple. If you were working on a business application, you were running on a mainframe. You had a particular process. When I started, in fact, relational databases weren't even necessarily that common, although they did at least exist. But architecture used to be simple. and we didn't really have to talk about it much. Architects sat off to the side and they dealt with IBM. And programmers just sat and wrote their programs and submitted them to the central authority to be executed. Technological change used to be slow. When I started, it was actually practical to think about having a 5 or a 10-year technology roadmap. Can you imagine that today? Think about how much change has been introduced only in the last 5 years. But it didn't used to be that way. And then things started to change. Although there is some dispute on whether or not he actually said this, Watson is quoted as having said, the worldwide demand for computers, I've heard it's either 5 or 7. Of course, when he thought computer, he was thinking those massive house-sized things that existed at that time. The president and CEO of the now defunct Digital Equipment Computer Corporation is claimed to have said, there's no reason anybody would want a PC in their house. It was only a few years later that the IBM PC came out. But even at the time that he said it, people already had Ataris and other systems in their house. But this PC revolution actually changed the way we thought about software architecture. And we had this thing called client server, where there were things that ran in the central place, the server, and then there were things that ran on the desktop. And this is when the pendulum started to swing away from very centralized technology organizations, because all of a sudden people had all of this power on their desk. We don't really think about it today, but what you could do with things like Access databases was enormous, and Excel spreadsheets. And so people started implementing more and more applications themselves because IT was too slow. Does that sound familiar to you? We've been hearing that since the 90s. And then came the Agile Manifesto. And we got to think about the principles of Agile. And we got to think about how to do software differently. And some of the principles that are most relevant in this context: the need for rapid feedback, the need for empowered teams, the need to push decisions to as close to the people impacted as possible, the transparency, and one of my personal favorites, the unambiguous definition of done. I did start programming in the time when your supervisor would walk over to you and say, what percentage complete are you? And you had to make up a number. And programmers, we were always optimistic, which is why you spent very little time 0 to 90% done, and a whole lot of time between 90 and 100% done. We understand things are either done or not. We understand that you and I have to agree what done means. And through some of the principles of evolutionary architecture and the techniques, we're moving that definition into architecture as well. And now things are really getting interesting. Think about how the compute landscape is so very different because of mobile and cloud. You're going to hear about some AR, VR stuff today. What about Alexa and the fact, I was in fact on a call with a client, and they said something that set off their Alexa. These devices are sitting around listening to what we are saying. What about the Internet of Things? We've got this explosion of different options in how we think about compute. And we're getting the same kind of thing even on the software side. I was so excited when people finally started taking something other than a relational database seriously, because not all data is relational. And even if you're not using a NoSQL database, or you're not currently using some aspect of the technology landscape, it's going to affect how you make architectural decisions. Brief detour into the history of Agile. And I want to talk about this really in the context of how it affected how people did their work. Because Agile did really spread out from developers. And the testers used to say, well, I can't test it until it's all done. And analysts used to say, but I have to be able to lay out my entire user journey. And designers used to say, I need to be able to make everything pixel perfect before I give it to you. All of those mindsets were predicated on an assumption that things weren't going to change. But things do change and have been changing. Now let's think about patterns. Again, architecture is not just about the big stuff. Software architecture is about the small stuff. And one of the first changes that came about was this notion of emergent design, rather than somebody, and I'm going to use object language, but really the concepts apply even outside of object orientation. It used to be people would draw their entire object hierarchy and then they would hand it over to people to implement it. And one of the things that we learned in Agile is actually what you want to do is you want to write the code that you need to implement what you have sitting right in front of you. And this design is going to emerge. Now, I'm very comfortable using the word emergent with respect to design, and we'll get back to this point in a moment. But it's appropriate here because regardless of the kind of code that you're writing, we can probably all agree whether it's good code or bad code. Good code in a retail setting, those same patterns, those same structures will still be good code if you're in a healthcare application. And one of the early things that we got out of the Agile movement was this notion of the continuous integration loop and how we can use the notion of continuous integration and that safety net to make small changes that will allow us to make changes that we would have been afraid to make before. You can make larger scale changes if you've got the right kind of safety net, and if you make those changes in the smallest quantum possible. Then we started to think about patterns at the overall enterprise level, excuse me. The book, Patterns of Enterprise Application Architecture, looked at what are the different ways we build up from these smaller components into an actual enterprise application. And the subsequent book helped us understand the various ways that we can connect systems together, the various ways different aspects of our architecture will coordinate their activities and communicate information. But one of the most important books, I think, in this sequence is a book called Refactoring Databases. And if you take nothing away from this talk, and if you haven't read this book, you should read this book. Because when I talked about all of the different roles and their adoption of notions of incremental change, the one role I have always felt who had the best argument for why they needed to do things up front were the DBAs, because data migration is hard. And so this Refactoring Databases book looked at what are all the small scale changes that are involved in changing a relational database, and how you can decompose large scale changes into these very smaller refactorings. And remember, that's really the definition of the word refactoring, is small modifications, not I have to refactor my code base because it's terrible. This is that original use of the word refactoring. And by decomposing these big schema changes into the small ones, you're able to simplify the migration process. So we're using this same mechanism that we use in code and this safety net to be able to more precisely pinpoint what are the problems in my data that's causing my migration to fail. The next thing came around, how do these different things work together? And I'm, missing a fair amount of architectural history here. We don't need to talk about things like object brokers and such. But there was this whole argument of should things be RESTful or should it be SOAP? And then, of course, the whole service-oriented architecture revolution. This was an interesting time in architecture where people were really trying to grapple with what is the best way to make systems more readily able to change. And that was really the goal of service-oriented architectures. But they never really went anywhere. And one of my hypotheses about why they didn't go anywhere is that these service layers were being built by us, by the IT departments, based on what we wanted people to do or what we thought people wanted to do. Flipping these contracts around, the notion of a consumer-driven contract, you're responding to somebody's actual need. That's one aspect that I think helps microservices architecture succeed where the traditional service-oriented architecture failed. So now we have microservices. And you can get all kinds of flexibility, all kinds of evolvability with using a microservices architecture. But there's a great blog post on martinvalug.com about how you have to be this tall to be able to really support a microservices architecture, because there are lots and lots of moving parts in a microservices architecture, and you get tremendous benefit, but you pay a cost. There are failure modes that you simply don't get in other architectures. And microservices would be very difficult to support without the underlying disciplines of continuous delivery. And so what some people have found is we're starting to hear people talk much more fondly about monoliths now. Back when the services revolution started and through with microservices, monolith, bad. Small service, good. Well, people are starting to recognize that actually there is a simplicity to a well-structured monolith. And maybe you don't necessarily need something as complex as a microservices architecture, that you can use a well-structured monolith to achieve the same kind of flexibility. Now, there are issues. It's actually much easier to create a big ball of mud in a monolith than it is in microservices. It's sometimes just so tempting when you're trying to get something out the door to just reach over into that other part of the monolithic code base. You can't really do that in a microservices architecture. But I believe we've gotten past the point of the knee-jerk automatic monolith must be bad to think about when are we willing to pay the cost of a microservices architecture to achieve the level of evolvability and changeability that microservices give to us. So the monolith is definitely not dead. Long live the monolith. And so we come to evolutionary architecture again. This whole notion of evolutionary architecture maintains that we cannot predict where change is going to come from. And also that there isn't one definition of what constitutes a good architecture. One of the early systems that I worked on when I came to Thoughtworks was a trading system. And when I say trading system, you all start thinking low latency, high throughput, performance is key. got to process them all. This particular trading system, in their wildest dreams, they figured it would do 100 trades a day. 100 trades a day. They didn't care about latency. They cared about never, ever losing a message, because each one of those trades was worth billions of dollars, even in the early 2000s. So a good architecture for the trading system that I was dealing with had much more emphasis on the communication infrastructure and how messages passed and how we monitored the status of messages as they went through the workflow. That architecture looks very different than an architecture for a more traditional trading system. We can't say what a good architecture is. We've got all kinds of ways we can say what a bad architecture is, but there is not one good architecture. And this is why, while emergence works very well when we talk about code quality and design at the code level, emergent doesn't work at the architecture level, because we have to introduce this notion of guided, this notion that these are the critical success factors that I have identified as an architect for my system. And continuous delivery, this whole idea of how we deploy, is a significant enabler of much of the architectural innovation that's occurred, because we really couldn't do microservices, particularly, in these places where they have dozens of microservices. Can you think about what an operations nightmare it would be for operations to have to manually deploy all of those different microservices and not get one thing wrong? Continuous delivery is often thought about in the, I'm a developer and I check in code and it appears in production. To me, the most important part of continuous delivery is the fact that we are de-risking the deployment of code. And so we can focus our problem-solving efforts on what are the changes that we've made and what might have possibly gone wrong as a result of the changes that we made, knowing that all of that other stuff is right. We know what's there. We don't have to think, okay, this is that server that has this weird configuration over there. Debugging in that context is very difficult. We should not be doing many of the architectural innovations that exist now without the foundation of continuous delivery. And I believe that we are going to continue to see new innovations in architecture as a result of the fact that we have this continuous delivery safety net. Much like long ago, we were able to make more sweeping changes in code bases because we had the continuous integration safety net. So I want to argue that this ability to evolve a system should be a first-class ability, just like maintainability and scalability and elasticity and all of that, which also means that there may be times when it's not important. Not all systems have to be elastic. Not all systems have to have 5 nines of reliability. Not all systems have to be evolvable, although the likelihood that you want to care about evolvability increases as the complexity of the overall enterprise architecture increases, because there are just more things that could change. So now what's the future? I spent a lot of time telling you we can't predict the future, so don't worry. I'm not going to tell you what the next great architecture is going to be. But I do believe things are going to continue to evolve. We are going to see new approaches, whether it be in the way different components within our system interact with each other. Maybe it is driven by some old ideas that get repurposed. I remember years ago when I was studying artificial intelligence and people would talk about blackboard architectures. and how you would put a problem up on a blackboard and have lots of different modules come in and try to solve it. That's actually something that we could be taking advantage of today. There are many, many different innovations that I think are going to continue to occur because of the enabler of things like continuous delivery and some of the rigor around supporting architectural change that we get from notions of evolutionary architecture. But what are some of the things that I think are probably easy calls to make? We've talked about platforms for a long time. And in fact, it's one of those words, kind of like refactoring, where it means so many different things to so many different people. Uber is a platform. SAP is a platform. Those are very, very different things, and they're platforms in very, very different ways. We can, for the moment, identify roughly 3 classes of platforms. And the first is this platform that's really more about developer productivity. What can I do to make it as easy as possible for my delivery teams to get new functionality out the door, to serve the business, to serve our customers? And these developer platforms and they go by many different names. One of the key success factors for those platforms is how happy are the people that are using it. We want to think about the developers, the development organization, as the customers of that delivery platform. Going a bit up the stack, if you will, we have business capability platforms where you start to think, what are the fundamentals of my business? What are the key concepts and the key processes that make up the value creation that my organization does? And how might I make it easier to reconfigure those things, to develop and deliver new services to my customers, or to make my internal processes more efficient? So this is now operating more at a business capability level as a platform. And then you get to things like Uber, which is really a platform as a business model. I think we are going to continue to evolve our thinking of where we can use platforms, how we can use platforms, what those platforms should look like in terms of the way they interact with each other. Ecosystems of platforms are forming. If you think of travel aggregator sites, many of those hotels would far prefer that if you went to their website to book the room instead of one of those travel aggregators. But they've all decided, well, we've got to play nice because so many people are using these aggregators. So there are pressures for people to enter into ecosystems of platforms, even if they don't necessarily want to. I think all of our systems are going to become increasingly distributed. Computing is happening in more places. And ironically, I'm talking about this in the context of a massive centralization that has occurred when we think about cloud. From a where do the cycles happen? Cloud is centralizing our compute, but we're not as tied to that physical structure as we were when I started programming so long ago. And so how we are constructing applications in the cloud are increasingly distributed. We're also seeing this from the perspective of how do I get scale? For a long time, Moore's law was just raising the capabilities for everybody completely for free. But we can't solve the scale of problems that we are trying to solve by just building bigger and bigger machines. We are going to have to think about, how do I scale horizontally as opposed to just scaling vertically? And so all of the discussions we had years and years ago about how to get distributed systems to work are coming back. In fact, there's an interesting series that is being rolled out on martinfowler.com by our colleague Unmesh Joshi on patterns of distributed architecture and looking at some of these fundamental problems of distributed systems. But the world is going to be increasingly distributed. And I think it's also going to be increasingly heterogeneous. When we think about the proliferation of IoT devices, we are going to increasingly be solving problems that we just can't solve on one little device because we want to get information from here. We've built a digital twin of our field, and we have sensors that are operating, and some of those sensors are smarter than others. The data streams out of some of those sensors need to be processed more locally. Others, that data stream can be processed more centrally. So the physical architectures that we are dealing with are going to be increasingly heterogeneous in addition to distributed. And so we're going to have to think about questions of data locality in different ways. One of the projects that Thoughtworks has been involved with over the years is the square kilometer array. And at one point when I was working with that, they were saying that one observation, even after the initial pass of noise filtering, was going to be 6 petabytes of data, one observation. You don't move that kind of data around. So in many ways, some data is going to move to compute, some compute is going to move to data. And the role that data architecture plays is becoming much more complex in this heterogeneous world. So problems of heterogeneous architectures, how do I decide what compute goes where? How do I decide what data to keep? Where to keep that data? How to store that data? These are questions that in the past we haven't had to ask in the same way. As I said, how excited I was, when we finally broke out of the cage of thinking all data must be relational because relational databases is where we put data. That change in the way we think about data architecture and the relationship between data architecture and compute architecture is significant. And it's going to change the way we develop systems, the way we decide what is good or bad about systems. Now, none of these predictions are startling. They're almost blindingly unable to be false. And I realize that makes them not quite as exciting as saying, I know what the next iPhone, innovation is going to be. But I think these are all pretty safe bets. I am excited at the prospects that we are going to have continued innovation in architecture, much like we've seen continued innovation after a long stall in programming languages. When you get some key enablers out there, we as an industry are all about solving problems in new and creative ways and solving problems that we didn't know how to solve before. And I think that's going to result in new approaches to architecture so that this history can go on. Thank you very much.
Rebecca, thank you so much. And I know in particular, as somebody on the West Coast, this was quite an early start for you. So we appreciate you coming in and kicking off our XConf North America. We do have a few minutes if folks would like to ask questions. Throughout the talk, as Rebecca teed up various artifacts of thought leadership. Scott was doing a really good job of trying to paste in the links. So we definitely encourage you to follow those links and get a little bit more detail on some of what Rebecca teed up. But we also have this Q&A function button at the bottom of the Zoom toolbar, and happy to use that to relay questions to Rebecca. I'll sort of act on behalf of the audience. One did just come in the chat from Jia Young, Rebecca, which is interested to know your thoughts on cybersecurity, presumably in relationship to evolutionary architecture.
Enterprises should be worried. There's a power asymmetry when we think about cybersecurity, in that any given enterprise has to defend themselves against all hackers. And hackers can decide, I want to go after AT&T, Bank of America. So they can concentrate all of their techniques and all of their thought on one target. But any given target never knows which hacker might decide they're the ones in the hot seat. And so they have to defend against the entire landscape of all of the different evolving attacks. So yes, I think enterprises should be worried about cybersecurity, and it's definitely a big part of how architects need to think about their systems. That said, security also doesn't have to be the Department of No. Very often, these security teams are seen as, you know, I'm going to police you. And of course you can't do that. Of course you can't do that. Of course you can't do that. Much like other aspects of compliance, of operability requirements, we think the security teams need to be more involved in deciding, okay, what is the appropriate level of security for this? And how do I ensure that my security needs are met? And so cybersecurity is critical, but we, much like we have with other functions, we have to learn how to get that into the cycle of our architectural decision-making as well as our development processes.
Yeah, it's a great point. I was reflecting on the point you made around increased distribution, and you even see that in security with this push towards zero trust architectures, where authentication, authorization decisions are getting pushed all the way to the host, you know, sort of alongside the microservice architecture.
Yeah, I think things like that is just an acknowledgement of the world that we have. And of course, the complication with bring your own device and endpoint security and all of that is, it just adds a complication. Our devices mean more to us. And that's not what a security person wants to hear. They don't want to hear that I have this thing that I'm going to be connecting to their device. It's like, no, I'm going to tell you exactly what it looks like. Well, maybe, perhaps not. So our expectations as users of technology are definitely bumping up against the comfort level of people in information security.
So we have a good controversial question, which I appreciate, from Scott Mitchell. Do you think there will be a reversal of the microservices movement, the return of the monolith?
I don't think microservices are going to go away. I do think there are people who get on the microservices bandwagon without really understanding the costs that they're paying. And sometimes they're doing it inappropriately. I remember there was a time, Thoughtworks has an internal list called software dev, where people post questions to try to, extract insight from what we call the hive mind. And at the very same time, there were two separate threads going on. One was, our client has about 85 microservices and we need to figure out how to reduce the number. And a separate thread, My client has 3 microservices and we need to figure out how to break them a little further apart. We are still learning what is the right level of granularity. How do we decide where to draw the boundaries around microservices? And a lot of that comes from a deeper understanding of the actual architecture and the problem domain. And so one of the things that we're starting to see a bit more momentum around is, unless you really know the domain well, you might want to start with a relatively simple architecture, and maybe that is in fact a structured monolith, and start to break it apart as you understand where the seams really are. Because getting the seams wrong in a microservices architecture is much more problematic than getting your component boundaries wrong in a structured monolith. You're just buying yourself more hurt. And so I firmly believe that microservices are here to stay. And in some applications, they are exactly the right architecture, and it's worth paying the cost. But it's like any hype cycle. Oh, everybody's got to do microservices. Oh, microservices are really hard. For some applications, particularly early in their life cycle, when you're still trying to figure out which end is up in the domain and how you can best solve the problem, you're probably better off with a well-structured monolith. But I keep saying well-structured because one of the things that we have learned is the only architecture that is really not at all evolvable is the big ball of mud. If you get this messy, entangled monolith, you're not going to be able to change it. And so it still matters to focus on, am I drawing my boundaries correctly? Am I respecting those boundaries? Am I respecting my layers? Am I not reaching across there into the monolith just because it's convenient?
Yeah, it's all back to the dreaded trade-offs again that you talked about.
Well, and balance. I'm just, I'm a pragmatist, and there is no perfect architecture. There is no perfect programming language. There is no perfect operating, no perfect, doesn't exist.
So we had a couple that came in the chat. So let me go to Ryan Kenworthy. Can you expound a little bit on the idea of business capability platforms? It seems like a key idea to move forward enterprises that still view IT as a utility or cost center.
Right. So when there are actually, as I said, some parallels with how we think about drawing boundaries in microservices, where you are going to say, let's say I am a retailer. There are certain things, certain business capabilities. I need to be able to sell things. I need to be able to ship things. I need customers to be able to figure out, where their order is and update their status and all of those things. And so there's some fairly standard business concepts that are independent of the technology. Now, in the SOA version 1 world, we as IT would have said, okay, well, I have my inventory system, so I'm going to provide a service which gives access to my inventory system in this way. Please go forth and use it. That's a technologically driven architecture, not a capability driven architecture. Because as we think particularly about some of the more complex business capabilities in today's organizations, they don't all live in one place. We can't have an architecture that is driven on the basis of the decisions we may have made in our selection of a particular package with some particular things around it. The business people don't care whether something lives in an inventory system or not. They care that they know how many widgets they have. And so when we start talking about business capabilities, the systems need to go to the background. And it's like, okay, what are the questions that our users are asking us? What are the questions that our customers are asking? What are the questions the internal functions are asking? And let's build that as a business capability. And if we get that right, and if we get it in the way that our business actually functions, if it's mapping, if you will, to the value stream of how we deliver value either internally or externally, if we've got those right capabilities, the people who are coming up with new ideas, those are the blocks that they're going to be moving around and saying, okay, I want to bring in this view and this view so that the customer now has this. And it's these views, that's the business capabilities. And so we are able to more rapidly respond to requests because we're actually, that layer is not, here's an interface into SAP, but here's a way to understand what our order stream looks like. And, I really like the way you tacked on at the end, the utility cost center, because I actually believe at the time Nicholas Carr wrote that book, that is how IT departments viewed themselves. They viewed themselves as a cost center. This was, the .com bust, okay, all of that technology stuff, all of that digital stuff, that's not very important. We just need to keep the lights on. And so as a CIO, my job is to run this thing at the least possible cost. And how do you do that? You standardize and you stabilize. You don't change things. And as long as you've got that view of what success looks like, of course, you're not going to want to deploy new functionality. It might break something. We can't do that. And so part of the transformation, the organizational and cultural change that has had to happen is to say, yes, there are still some utility functions in IT. There are some things that should just work. No organization who isn't in the business of delivering payroll for others should try to differentiate themselves on their payroll system. You just want to make sure people get paid. Those things you can treat as a commodity, you can treat as a utility. But if you try to use that same mindset for the system that is allowing you to interact with your customer, you can't deliver value. And that's the split. And I think by focusing on those business capabilities, it demonstrates to the rest of the organization that the IT department does understand, hey, our business is to deliver value for our customers. Our business is not to upgrade SAP.
Right. We have, we had one that just came in from the audience. Let me ask that from Didier. So thank you, nice talk. Evolvability is an interesting quality attribute, but should we not go one step further and consider disposability? It seems to be taboo, but all trends seem to converge that direction.
That's part of why I mentioned that evolvability isn't any more absolute than any of the other abilities are. Because there are some cases where it makes more sense to throw it away. Maybe it's small enough that you can dispose of it. The granularity of it is one issue to be considered. It is a non-trivial undertaking to dispose of something on the scale of SAP or Oracle Financials or something like that. And there are fundamental parts of the business that have to change radically if you want to dispose of something key like that. On the other hand, some of the services that we provide that are customer facing, we may decide actually it's better to make that disposable. And there are also times in the life cycle where you want to think about things that are disposable. When you have, for example, when you're creating a brand new product, you may not really know what that unique differentiation is or how you're going to get there, or maybe what is the process that you're going to use to come up with the end result. Worrying about maintainability and evolvability when you don't even know what it is supposed to do doesn't make sense. And so I do agree that we need to be able to say it is better to throw this away than worry about keeping it evolvable or maintainable. I'm not a fan of the idea that all aspects of an enterprise are going to be disposable, because changing out some aspects, the organizational ripples are too great. Change management is real. And as much as we as technologists keep saying, the technology is going to keep changing, we have to keep changing, we have to keep adapting. Organizations as a collection of people have a change limit. And so I think we do want to be careful of just how universal we get on the disposability. But I agree with you. I do think that disposability should be up there on that list, and some things it makes far more sense to throw away than to try to fix.
Thank you, Rebecca. We'll end with a final question from my partner in crime as co-host for the conference today, from Scott Davis. Can any architecture be evolutionary, or does that concept have to be baked in from the beginning?
I don't think evolutionary is a binary. I think there are things that you could make any architecture easier to evolve, to make it more evolvable. But there are degrees. In the precise definition we use in the book, you're looking at a deployable unit. And so, the level of evolvability of a monolith, well, you have to deploy it all together. So that's, you can't think about evolvability past that. Although there are ways that you can still make that monolith as that independent deployable unit more evolvable itself. So there are characteristics that make a particular architecture more evolvable. And there are techniques that, regardless of what your architecture is, it will increase your ability to evolve the architecture. And so, yes, I think any architecture, except the big ball of mud, is evolvable. The big ball of mud is beyond hope.
Well, thank you again for kicking off XConf for us and getting us off to a great start, Rebecca. And thanks again for the early start that meant for you. We're going to take a 15-minute break, so we will rejoin the next speakers on observability and digital transformation in 15 minutes. So it'll be 10:15 Eastern time. And between now and then, as Scott said, take a break, get your coffee, stretch. We'll give some nice background music for everybody to relax to. Rebecca, thank you so much.